Hello, I'm very glad to be here and thank you all for coming. I'm very glad to have this opportunity to talk to you all about my research. Uh, I, I spent a lot of time on this project, starting on this, working on this in Munich, and then have continued it, and it's a long process which results in a book that scholars read, so it's nice to have an opportunity to be able to actually have an audience of dozens of people to listen to what I do. So what I'm working on is a critical edition and translation of the text contained in this book. And at first glance, this book is perhaps not all that exciting looking. Brown cover, you can tell it's old, but not too much else. You look inside, and it's filled with Latin, and you look at the pictures on the side, it's filled with geometry. It's a mathematical treatise on astronomy. Okay, here's the title page, and let me explain the title a little bit. The Epitoma Ioannis de Monte Regio in Almagestum Ptolemei. Okay, what does that mean? Okay, well, an epitome, I'll translate this for you into something approaching English. So the epitome here means that it's a abridgment or a summary or a reworking. Johannes de Monte Regio, that is this fellow here, one of the two authors of the book, actually. The other is not credited on this title page here. We'll get to the other one later. And this guy, Johannes, is normally known as Regiomontanus now. He gave the Latinized form of his name. Okay, so it's the reworking done by him of the Almagest of Ptolemy. Okay, well, what's that? The Almagest is another book, and it's written by Ptolemy, who's this guy here, who's with a crown on his head due to a confusion. He's not actually a king, but I guess king of astronomers, maybe you could say. Well, this book here that you see in front of you was printed in 1496. The book that it's a reworking of, written by Ptolemy, was written in the 2nd century. So here you have a reworking of a scientific work 1,300 years after the first book was written. It seems like this is going to be an out-of-date work. But I hope to convince you actually that this book does have an important role in the history of astronomy, and also it has a pretty exciting story behind it. Okay, so first what I'm going to do is I'm going to talk about Ptolemy first and the Almagest, so the book that the Epitome is a reworking of. I'm going to talk about Ptolemaic astronomy, briefly go over its history up to the 15th century. And then I will talk about the two authors of this book, not just this fellow on the right, but also his colleague. And then I will get a little bit into the content of the epitome, what's different in here, what is different between the epitome of the Almagest and the original Almagest, and then I'll talk about its role in the history of astronomy. And as we go through this, I'll also talk about the patron of this book who commissioned it and the reason that this book was written. Okay, so we'll begin with Ptolemaic astronomy. So Ptolemy, as I said, was alive in the 2nd century, and he is most famous for his book, The Almagest. The Almagest is his masterpiece, his comprehensive overview of geocentric astronomy. Here we have a model of the universe, a tool for teaching Ptolemaic astronomy, and the black ball at the center is the Earth. You see hoops around it, and the signs of the zodiac. This astronomy of Ptolemy tries to explain things in terms of circular motion, that is regular. Here's a Latin translation of the Almagest, and this is actually the translation that the authors of the Epitome would have used, or that they did use, but this is a printed version that was printed in 1515, not the manuscript forms that they actually would have been using. Okay, so let's go over what's actually in the Almagest. The Almagest first lays out the basic cosmology, things like the Earth is round, it's at the center of the universe is round. What are the two main motions, that the fact that the Earth does not move, these sorts of things. There's a brief section going over this, there's a brief section going over introductory mathematics, and then there is those sections are relatively short, but most of the work is filled up with the nitty-gritty details of explaining models that will work for telling us where the heavenly bodies are and predicting where they will be in the future. Here's a very schematic drawing of the Ptolemaic universe. You have the Earth in the middle, and also the other four elements there. You have water, air, and fire. And then we have a separate ring for each of the heavenly bodies. We have the moon, we have Mercury, Venus, we have the sun, Mars, Jupiter, Saturn, and then that's it for planets, right? This is long before telescopes. And then the fixed stars. This is the basic arrangement of the universe. But this, again, is a very schematic drawing. The Earth was understood to be basically a point, a minuscule point in comparison with the immensity of the universe. And also, each of these rings that's given to a heavenly body actually would have necessitated several circles to give us any sort of accurate representation of the motion of the heavenly bodies. I'm going to go briefly over a couple of those circles that we would need to explain the motion of the heavenly bodies. Here, for example, is Mars, and this is an animation made by Dennis Duke. And here we see P for planet, I guess. And the planet is moving around on a little circle. This little circle is called an epicycle. And that circle is moving around on a bigger circle, which is called a deferent, either because it moves and carries around the epicycle. But it's also called an eccentric because O here is the Earth. Let me make that move again. O is the Earth, but the center of the big circle is actually this point here. And then there's yet another point that regulates the motion of the epicycle on the big circle. And that's this point called the equant point. And Ptolemy doesn't get into this in the Almagest. He does in another work. And most medieval scholars understood that these sorts of models that use circles actually presuppose that there are physical or three-dimensional orbs, spheres that are causing the heavenly bodies to move. So here we have, again, a tour of the cosmos, another animation here, starting with Ptolemy's map of the Earth, and then we'll zoom out, seeing all the orbs of the heavenly bodies, going all the way out to the fixed stars. So this is the system of the universe. And the whole thing is whirling around us once every 24 hours to give us night and day. So this conception of the universe that was given in the Almagest was the dominant one for basically a millennium and a half. And the Almagest was the most authoritative work, or the standard for this sort of astronomy. The Almagest was translated into Arabic, and in the Arabic tradition, there were many commentaries written on it, and a lot of these commentaries are very interesting, where the Arabic astronomers would go into alternate models, figure out different ways to make the planets move by different arrangement of circles, or changing, due to their own observations, changing the sizes of the circles and the speeds that things move. In the Latin West, there wasn't quite so much going on. The Almagest was not translated into Latin until the 12th century, and then it was translated 3 times. The most well-known version was made by a guy named Gerard of Cremona, who traveled from Italy to Spain and ended up translating many, many works, a lot of mathematical ones, but he went to Spain to find the Almagest and to translate it. That's what his students say. The Almagest was not taught at universities normally. The 2 standard textbooks of Ptolemaic astronomy were the De Sphera and the Theorica Planetarum. These were relatively basic books that gave an overview of Ptolemaic astronomy, but without getting into the details. This does not mean, though, that the Almagest was not read. People did read it. There are, I think, 40 or 50 manuscripts that survive. People wrote it out by hand. They obviously cared enough about it to do that work and to have a copy of it. And copies of it are often filled with marginalia, showing that people indeed read and used these manuscripts. And occasionally, it was taught at universities. Here we have an example of a manuscript of the Almagest, and we have a lot of marginalia there. And at the beginning of the manuscript, there is a little horoscope, which is not the horoscope for a person, but a horoscope for the date on which a certain master, Johannes André Schindel, began to lecture on the Almagest. He gave lectures not as part of the ordinary course of studies, but he gave them on holidays. So on holidays, when ordinary lectures were not going on, he would lecture on the Almagest. And it took him the better part of a decade to get through the whole Almagest, going through it on just every once in a while, these occasional lectures. There also were a number of commentaries written on the Almagest. Before the Epitome Almagesti, the book we're talking about today, there were 15 commentaries written. Some of these were translations of Arabic works into Latin. Most of them were original Latin works, but most of them covered only parts or aspects of the Almagest. Very few covered the entire thing. Okay, with that, I think we can get to our 2 authors here. The 2 authors of the Epitome Almagesti. First, Georg Peurbach and Johannes Regiomontanus. Georg Peurbach was born in the town of Peurbach in Austria, and Johannes Regiomontanus. Regiomontanus is a Latinized form that derives from the Latin name from the town he came from, Königsberg. It turns into the King's Mountain, turns into Regiomontanus. He actually never called himself this, but this is the name that stuck later. These 2 guys both studied at the University of Vienna, and that's where they met. As I said, the university teaching usually stayed on a fairly low level, a fairly rudimentary level. But Vienna had some things that did make it an excellent place for both of these guys to learn astronomy. There had just been recently, earlier in the century, there had been a scholar, a professor, John of Gmunden, who was one of the first university teachers to focus on mathematics and to primarily teach mathematics and astronomy. Nearby, there's also the prior of a monastery who was very interested in astronomy and brought in fellow astronomers, welcomed them into the monastery, and who had many manuscripts written of astronomical topics. Both of these guys died a few years before Peurbach came to Vienna. So they never met him, and they did not have a direct impact on either of our 2 guys, or either of our 2 authors, but their manuscripts were around and are our two authors did use those, and also there may have been associates of these two proponents of astronomy around in the years following their death. So after Regiomontanus came to Vienna in 1450, when he was just barely a teenager and entered the university, it was probably fairly soon after that that he met Peurbach. They both were very interested in astronomy, and even though Regiomontanus never formally studied under Peurbach, he never attended any lectures given by Peurbach, it doesn't look like, he did become a sort of disciple, and he called himself later in life a disciple or a student of Peurbach. After he became a master and began to be able to lecture at the university, Peurbach gave a set of lectures on one of those standard textbooks, the Theorica Planetarum. And he gave a set of lectures that turned into a textbook, a treatise that replaced the older version and became very popular. And this is often talked about in history books, partly because it popularized the teaching of the physical orbs, or the three-dimensional spheres, in order to explain the motions instead of just using circles. But actually, this is something that had been around for a while, but the older Theorica books did not always explicitly say that, even though they often had this almost identical figures to the ones you see here. So it's right about the time that Regiomontanus became a master in 1457 that they started working together frequently. They started calculating tables, making observations together. They both made instruments. They both cast horoscopes and did astrology, and they both were writing astronomical works during this time. It's interesting that Regiomontanus, who at this time was immersed in Ptolemaic astronomy, expressed some dissatisfaction with it. He actually started to work on an alternate system of astronomy. It's geocentric still, but it explains everything not by the models that we saw before, equants and eccentrics and deferents. It instead tries to explain everything with systems of concentric spheres with all different axes, and he tried to put them together into ways that would model the motions of the planets. He did this for the sun and the moon, and he promised in a letter, he wrote in a letter that he intended to write a full treatise that covered everything on this. He never wrote this treatise, and we only have a little bits of glimpses of the sorts of models that he was developing. While after they became masters, they did teach at the university. Peurbach taught, it seems like, every other semester at the university, pretty much, and he mostly taught actually on classical Latin authors, right? Teaching on Cicero and Virgil, these sorts of things, not on astronomy. And Regiomontanus taught a couple of classes at the university, one on the first book of Euclid and one on optics. But they both were looking around at this time for patrons, for powerful people who could support their work. And Peurbach seems to have been pretty successful at this. He became the astrologer to the teenage king Ladislaus, who is the king of Hungary, Croatia, and Bohemia, but who spent a lot of his time living in Vienna or in Prague. And Peurbach attended him on some journeys. He died, though, while still in his teens. And Peurbach was looking around for other patrons. And we can tell that he consulted and communicated with a number of people, including the bishop Nicholas of Cusa, or later cardinal, who's known for his philosophy and theology. The powerful Bishop Johannes Vites, who's involved in Hungarian politics especially, and he seems to have consulted for the Holy Roman Emperor Friedrich III. The patron who concerns us, though, arrives on the scene in 1460. He's this guy on the left, Basilios Bessarion, who is born in a town on the Black Sea, so in the Byzantine Empire, called Trebizond. And he was a monk. He advanced quickly in the church. Of course, being in the Greek world, right, he's a member of the Orthodox Church. The East and Western churches had split several centuries before. And he actually was part of the delegation that went to attend the Council of Ferrara and Florence, which attempted to reconcile the two churches in the late 1430s. This did not succeed. But he had worked so hard on unification that he actually emigrated to Italy and started working his way up the Catholic Church. He was made a cardinal, and he had a very large private library in Rome consisting of Greek and Latin works, and he became the center of a circle of humanist scholars. One of the members of that circle is the guy over here on the right, Georg of Trebizond. Georg of Trebizond, despite his name, was not actually born in Trebizond. He was born in Crete. And he came to Italy, moved to Italy when he was 20 years old, and he learned Latin and apparently learned it very well because he made his living teaching Latin, teaching eloquence, basically, and working on Latin style, and also translating works from Greek into Latin. Okay, a quarrel starts between these two men, though, starting in 1450, and it's going to build up over the course of the decade. This starts with a work that Georg of Trebizond writes that relies upon a particular interpretation of a Bible verse. It's the verse in the Bible after Jesus has risen from the dead. Jesus asks Peter 3 times, "Do you love me?" After that, he tells Peter basically that how he's going to die, and then Peter asks Jesus, what will happen to John the Beloved? What will happen to him? And Jesus replies in the translation that Georg uses, "So I will have him to remain." Well, Cardinal Bessarion unfortunately informs him that this is actually in the Vulgate, this is a faulty verse, and this should actually be not "so," but "if." This changes the meaning of this verse enough that George's whole argument has to be thrown out. So here you see a little bit of disagreement between these two men. It heats up a little bit when the Pope asks Georg of Trebizond to translate the Almagest. Bessarion gives Georg a manuscript of the Almagest, a Greek manuscript from which to make his translation from, and he also gives him some friendly advice. He says, if you're going to translate this, why don't you look at the commentary written by Theon of Alexandria? This will be a great help to you. Georg quickly makes a translation of the Almagest, and he also writes his own commentary on the Almagest. In this commentary, he goes on at great length about how Theon and other commentators on the Almagest didn't really understand it and were the cause of errors and misunderstandings of Ptolemy's Almagest. So Bessarion here is angered by this rejection of his advice here. His favored commentary has been put down by Georg. Georg submits this to the Pope, who has somebody look it over and declare that it is not that great of a translation or commentary. And the Pope doesn't receive it. Doesn't accept this gift of a translation and commentary. Georg of Trebizond sees Bessarion behind this and is in turn angered at him. Okay, this gets even worse. In 1453, Constantinople falls. It's taken over by Mehmed II, Mehmed the Conqueror, and almost immediately after it's taken over, Georg of Trebizond writes to Mehmed, trying to persuade him to convert, but also expressing George's own wish that Mehmed conquer Rome and, in fact, become the universe of the whole world and the whole universe. Georg is excited about this because he thinks that this will help usher in the apocalypse. Bessarion is not sees the Ottoman Turks as the enemy. He's going to be trying to drum up support for a crusade against them, actually. And he sees these overtures by Georg to Mehmed in a very bad light. Then on top of this, Georg writes a work, a comparison of the philosophers Aristotle and Plato. He denigrates Plato in this, and he doesn't remain just on the philosophical level, but he blames Plato and Platonists for many evils. Bessarion was trained under a famous Neoplatonist, or Themistus Platon, and he considered himself a follower of both Aristotle and Plato. So Bessarion takes this attack on Plato and Platonists apparently personally, and he spends a lot of the next decade writing a large response to this. Okay, so this is the situation in 1460 when Bessarion is made a papal legate and is sent to Germany and Austria to find support for a crusade against the Ottomans. He goes to a few different assemblies in Germany and then goes to Vienna in May of 1460, hoping to attend an assembly there, an assembly of lords. Practically nobody comes or even sends their representatives, so he decides to stick around and wait for another opportunity to talk to people in September of that year. He waits there from May till September. There's an assembly, and he can get no commitments of support for his crusade. People are too concerned with local affairs to commit to such a large undertaking involving travel far away. So after this, he tries to stay around to continue drumming up support, but also he's soon busy with a struggle that's brewing between the Holy Roman Emperor Friedrich III and his brother, the Archduke Albrecht VI. There's actually such fear of actual fighting breaking out between their forces that in Vienna, the university negotiates with the city about what the students should do in case of an attack, whether they should be required to man the walls or whether they should be free to man the walls if they want to, or to remain neutrally in their homes. And preparations are made all summer for this assault on the city. Luckily, there's a truce made in September of that year, of 1461. So Bessarion now is free to go home to Rome, but he spent a year and a half in Vienna, well, apparently not getting all that much done. But during this time, he met Peurbach. And we can turn now to Regiomontanus, who in his dedication letter to the Epitome writes about tells the story from this point. The way he tells it, Bessarion really wants to write a new translation of the Almagest because the existing translations are so bad, including George of Trebizond's apparently, that if Ptolemy came back from the dead, he would barely even recognize these as his own work. But he's too busy, so he asks Peurbach, who knows the Almagest practically by heart, to write some sort of a reworking of it, an abbreviation of it, abbreviated version of the Almagest. Peurbach does this, or starts to do this. He gets through the first 6 books, and then he finds himself on his deathbed. And Regiomontanus tells the sad story. Peurbach's lying there dying. His disciple, Regiomontanus, is standing by the bed by his side, and Peurbach says, "Farewell, my Johannes, farewell. And if you can have any memory of your devoted teacher, finish the work of Ptolemy that I leave unfinished. I say this to you as a testament, or will, I guess, that I, having finished life, but with the better part of me remaining, I shall fulfill the desire of our best and most beloved leader, Bessarion." Bessarion continues writing, Regiomontanus continues writing that it would have been almost sacrilege to not finish the Epitome after such a request. So what happens is Regiomontanus goes along with Bessarion to Rome, where he finishes the Epitome, probably in 1462. And he stays there with Bessarion for several years, doing a number of things and writing a number of mathematical and astronomical works in the process. Okay, now I think we can start to talk about the Epitome itself. Here are the 2 manuscripts that we have that were made for Cardinal Bessarion. And we have his handwriting in the margins here. These are the versions of the Epitome made for him. Overall, the Epitome follows the Almagest pretty closely. It covers the same material, it covers it in the same order, but there are a few changes. The first of these is that it's arranged in propositions. The Almagest is divided up into books, 13 books, and each of those into chapters. But within each of those chapters, there is a flowing narrative, you might call it, where proofs and calculations are joined together in a flowing text. They're not divided up and separated. Parts of the argument are not separated out and easily seen as parts. And this can make it a little difficult to navigate the text. The Epitome, on the other hand, follows the model of Euclid's Elements, which is arranged by propositions and proofs. Here you can see on the right, you have propositions that are arranged, that are given in bigger font, and then they're followed by a proof in a slightly smaller font. So for example, something like you might have a proposition, in an isosceles triangle, the 2 base angles are equal to each other. Something like that, a statement like that, and then a proof of that. And then the work is arranged in this way with statements and proof, statements and proof, statements and proof. Sometimes things that you actually have to do to construct a triangle, an equilateral triangle on a given line. But those sorts of short statements or things that you can do, followed by a proof that the construction is valid or a proof of the theorem. And here we see a page from the Epitome, and it's arranged in just that way, right? You have propositions, and the propositions are given numbers. They're in the printed version, given in a bigger font, and then the proofs are given in following them in a smaller font. And this makes the text more easily makes it more easily navigated, and it also breaks it up into pieces that are easier to learn. Another thing that happens in this change of format from a flowing narrative involving calculations and observations into a system that's arranged basically by proofs is that the level of universality changes. While Ptolemy works through a lot of examples where he shows a calculation and he gives a particular example and shows how he works through it, the epitome works on a universal level. So instead of multiplying two numbers together, he'll talk about the relationship between two arcs that he's calling AB and CD, for example. So instead of there's less numbers and less calculation and more more just getting straight to the point might be a way of seeing it. Another change is that all of the tables of the Almagest are taken out. If you actually want to do astronomy and to calculate and predict the position of the planets, you need tables. You're not going to get very far without them. But if you want to understand the theory behind the models, you don't need these tables. And so by taking these out, the Almagest gets streamlined immensely. Here, just a lot of the tables from just books 1 and 2. If we continue through all 13 books, we'd be swamped in tables. Along with the reduction of actual calculations, there's a reduction in the amount of discussion of observations. Observations are still discussed, but often in a much shorter version and without very many details. Modern mathematics, what do I mean by that here? I mean primarily the use of the sign instead of using just the chords of arcs, using the sign instead. This actually makes many of the theorems much less verbose than in Ptolemy's original version. And the other part of modern mathematics is a more advanced and simpler spherical geometry underlying the mathematical astronomy. The Menelaus theorem that Ptolemy uses is notoriously difficult, and it requires 5 known arcs in certain situations to figure out, to find one unknown. And it involves compound ratios, which opens up a whole new can of worms. There were alternatives that Regiomontanus uses that get around this, where you don't need compound ratios, and you end up with proportions where you only need 3 known terms to find a 4th unknown term. And lastly, the epitome includes not just the material of the Almagest, but also introduces some new parameters and also proofs, and these coming from, a lot of the time from Arabic astronomers, but also coming from the authors themselves sometimes. Of the Arabic astronomers that are cited and used, the main ones are Albategni or Albatani, Geber or Jabir ibn Afla, Arzakal, Arzakali, and Alpatrigrius, who is Albatrugi. So we have here some tapping into that richer tradition of Arabic astronomy in making that available in the Latin world. Now, this is not all new. A lot of these features we see also in a commentary on the Almagest or a summary of the Almagest written about 250 years earlier in Latin. The Almagesti Minor, the small Almagest. This does a lot of those same things. It's arranged in propositions, it brings in material from Arabs, it uses signs, but this only covers the first half of the Almagest. And actually, it's no coincidence, it seems, that Peurbach only got through the first 6 books, since an examination shows that what he did for his portion of writing the Epitome was basically taking this work from 250 years earlier, the Almagesti Minor, and rewording it and making some small additions to it. So most of the original parts the more original parts are due to Regiomontanus. So perhaps it is fair that in this printed edition that we saw, his name only is given there. I want to remark that it is notable that Regiomontanus finished this sort of commentary, this sort of abridgment of the Almagest and reworking of the Almagest, not just for part of the Almagest, but for the entire Almagest. Of the 15 commentaries that were available in Latin before he wrote this, only 3 covered the entire Almagest, 1 in a pretty superficial way. 1 was written by Jabir ben Afla, an Arabic astronomer, who focused on his critiques, parts of the Almagest that he didn't like, that he thought were done poorly or could be done better. And the third one is the one written by Georg of Trebizond, which, as we've heard, was apparently not that great. So completing commentary, an abridgment of the whole Almagest was quite a feat. In the introduction of things that were foreign to the original Almagest, one really important one that is uncited, he doesn't tell that he's doing this, is that he brings in, he proves a theorem involving planetary models and a rearrangement of the models in the equivalence of a rearrangement of the models that is taken, here's just that picture zoomed in, but this picture is actually in its fundamentals almost identical to one that comes from an Arabic work written 30 years earlier by Ali Kushji. And he apparently, we don't know exactly how, but somehow knew of this proof, it seems like. And this will come back. We'll come back to this one later. And the authors also, mostly Regiomontanus, but perhaps Peurbach had something to do with this. There are sections that involve insights of the authors themselves, or include the results of their own work. For example, they have a more detailed treatment of the equation of time. They give their measurement of the degree of slant of the ecliptic, and Regiomontanus brings up a problem of the moon's apparent size. Given the size of the moon's epicycle, it seems that it should show more variation in apparent diameter than it does. This criticism casts some doubt upon whether this epicyclic model is really showing what's really going on in the heavens, or if it's just some way of giving us location, the angle to the moon. Okay, I want to point out that Bessarion was not some distant patron of the sciences who commissioned a work and then had it written and then did nothing with it. It's clear that he read it. We have his notes in these manuscripts, and we also have even corrections made by him. Some of these are fairly trivial, maybe from an astronomical point of view, but here Regiomontanus uses the bastardized Latinized versions of many Greek names. So here we have Abrakis. Who's Abrakis? Well, Bessarion corrects Regiomontanus. This is the ancient astronomer Hipparchus, and his name has been corrupted into Abrakis. And this ends up in the second manuscript that Bessarion owned of the Epitome being corrected in the text. He makes this sort of correction all throughout the book, showing that he apparently read it fairly carefully. But it's not just his reading of the Epitome that we see. We also see in another manuscript that contains mostly Greek writings, we have some calculations done by Regiomontanus in his own hand. And what he's doing is going through parts of the Almagest very carefully and doing all the calculations, even ones that Ptolemy does not do. He's doing all the multiplications, divisions, finding square roots that are involved, that are implicit in Ptolemy's work. And then he writes it out again, maybe a second draft. Bessarion then copies this out into Latin still, but he makes his own copy of this. And then he translates it into Greek, apparently the language that he thinks best in. And then in another manuscript, we have him taking this translation into Greek, and he incorporates it into a fuller commentary on the Almagest. Now this, it seems to have been his modus operandi to work in Greek and to make drafts of works in Greek and then have them translated into Latin by some of his associates. And this is probably what he was doing here. It seems like Bessarion was trying to write a very detailed commentary on the Almagest, having Regiomontanus as basically a tutor guiding him through this, but then he wanted his own commentary that would show, it seems like, the purpose of this would be to show that he understands the Almagest so much better than Georg of Trebizond. Unfortunately, this commentary involves working in Greek, which I don't know, so I'll have to find someone to help me with this, to make any progress in this. An Italian scholar has looked at these manuscripts, and well, through his work, I have an idea of what's there, but he didn't work through all the math in there. So it seems like this was one prong of an attack on Georg of Trebizond. Another prong of the assault on Georg is this work here. It's called the Defensio of Theonis contra Trapezentium, the defense of Theon against Trebizond. So he's defending Theon, who wrote that commentary that Bessarion recommended to Georg of Trebizond earlier. He's defending him against Georg. And this is a fairly big work. It's 300 sheets, so close to 600 pages front and back. And it's filled with polemic, sometimes pretty bitter, filled with insults, making fun of that ridiculous old man who didn't really understand astronomy very well. And there also may have been other parts of this effort to discredit Georg of Trebizond. Here we have the King of Hungary, and right about the time that Georg of Trebizond goes to see him and tries to dedicate his translation of the Almagest to him, Regiomontanus ends up there also, and we have a very deluxe copy of the Epitome made for the king and his wife. Okay, so this gets us through the 1460s. Regiomontanus ends up, though, moving to Nuremberg, where he sets up shop as a printer, and he publishes a program, a list of works that he wants to print, mostly scientific works, including the Epitome. He dies on a trip to Rome in 1476 and never prints the Epitome. So now that both of our authors are out of the way, I guess we can turn to the work's influence. So the work is printed, though, in 1496 in Venice. One thing to keep in mind here is that the Almagest itself was not printed until 19 years later. In 1515, we had that edition of the Almagest. So while the Epitome all of a sudden goes from existing in a handful of manuscripts, there are 11 surviving ones, it suddenly goes to existing in probably hundreds of copies, of printed copies, while the Almagest still exists in only a much smaller number of manuscripts for about 2 decades. So in those 2 decades, it would have been much easier for people to come across the Almagest in the version of the Epitome, not in the original. The Epitome is also translated again, it's actually published again, in 1543 and then 1550. So here, roughly 90 years after it was written, it's being printed. George of Trebizond's commentary is never printed. His translation is printed. And this is it, printed in 1528, his translation of the Almagest. You see here in the margin, there are some additions printed. And these actually are excerpts from Regiomontanus's Epitome. So it seems like George of Trebizond can never win, even when his work is finally printed, that dang Epitome pops up again. I want to talk very briefly about the role of this work in education. As I said, the arrangement of this work made it more digestible, and it's praised by a number of people for its clarity and for its brevity in comparison to the Almagest. So among Lutherans, Philip Melanchthon, who is a famous educator, he praises it. It's also praised by Erasmus Reinhold, who taught at the University of Wittenberg and who is responsible for the Prutenic tables that took Copernicus's De Revolutionibus and used it to make tables. It's praised by him, and he also cites it off in one of his textbooks, one of his teaching works. It's also used by a colleague of his, Erasmus Floch, who praises it and writes that it's preferable to the Almagest for its comparable simplicity and its suitability for learning. In the Catholic world, let's go to the Jesuits, who were giants of education. In 1552, Geronimo Nadal, who laid out the curriculum for the first Jesuit college, laid out a course of studies, and he included it as a possible part of one of the astronomy courses in this course of studies. It seems, though, that he was overly optimistic. The standards for what was taught seem to have dropped pretty quickly and not included in later versions of curricula. Francesco Marolico, who taught at a Jesuit school, writes in his commentary on the sphere that was published in 1575. He talks about it as an example of how a lack of verbosity or verboseness can actually be good and doesn't harm the transmission of ideas. And he also includes the cosmological conclusions of many excerpts of statements from the Epitome, such as that the Earth is round, that it's at the center of the universe, that it's like a point compared to the universe, these sorts of things. And he gives these, unfortunately, he follows this with his opinion that Copernicus should be whipped, apparently, for not accepting all of these principles of astronomy. Christoph Clavius, who was very important to the mathematical teaching in Jesuit schools in the 16th and 17th centuries, includes many references to it in his commentary on the De Sphera, which was printed at least 16 times between 1570 and 1618. So in 1618, there are books being printed that refer almost constantly to the Epitome Almagesti. This work was also translated into Chinese, apparently, by Matteo Ricci. That would be neat to track down and see what happens, whether the references are also included in there. And Clavius also set out a proposed curriculum where he considered assigning the Epitome or perhaps writing his own commentary on it, and then assigning this to advanced students of astronomy. It's not clear that he did either of these. He probably did not, I would suspect. And let me go to one more person that was affected by the epitome. Copernicus in De Revolutionibus uses it quite often, and sometimes it seems that he refers to it in preferring it over the Almagest. Let's go back a little bit. When Copernicus came up with his heliocentric theory sometime before 1514, the Almagest was not readily available, right? This is before it was printed. So it's very likely that a lot of the Ptolemaic astronomy that he learned is actually learned from the epitome. And we come back to this proof in the epitome. This is the proof, it's first and second propositions of book 12. And this includes an added part of the proof that's taken not from Ptolemy, but taken from Ali Kushji, I don't know. It seems that this theorem played a very important role in the process that got Copernicus to the heliocentric system. There are a set of notes written by Copernicus sometime apparently before 1514, in which the notes match up with the numbers you would get if you were to take this theorem and apply it to each planet and try to figure out how big each circle would be. And it seems then that Copernicus took this theorem, played around with it, and transformed the Ptolemaic version of the planetary models into equivalent ones that then led him in turn to a heliocentric system. Okay, so then I'll conclude here. So we now see that this non-assuming book that we started with actually may have played a big role in the dramatic change from geocentric to heliocentric cosmology. But besides that, it stands at an interesting point at the apex of Ptolemaic astronomy. It's a work that was used to learn advanced Ptolemaic astronomy, and that was apparently read even in the early 17th century. It was used both by those who would form alternate systems and by those supporters of Ptolemy who now had to confront these new challengers. This story of the Epitome Almagesti, I think, also serves another purpose. It provides us with an excellent reminder that books filled with ideas, and here, in this case, even abstract mathematical astronomy, were shaped by the messy history of individual people. And I think an appreciation of the stories behind the books, though, makes us value the ideas in them all the more. Thank you.
And as a reminder, that book and a few others will be on display in History of Science across the hall after we finish with Q&A. And we do have time for a few questions. Raise your hand. I'll come by with the microphone. Brad, we'll start with you up here.
I have a couple different questions. First, the original book was written in the 2nd century. Why was there a sudden explosion of interest in it 12 or 1300 years later?
Yeah, that's a complicated question. Why were people interested in at that point? I think part of it is that there was an explosion in learning of all sorts at this time, right? This is part of this isn't just people were interested in the Almagest. People are become interested in Aristotle and Plato. They're interested in all sorts of mathematical works, astrological works, Averroes, Avicenna. All these people are being studied. And there's just slightly before their eyes of universities, there was a translation movement where a lot of people put a lot of effort into going out there and finding works that had been unknown or had been lost or were very rare in Europe.
Right. And what language was the original book written in?
Yeah, Greek. Greek.
Oh, it was Greek.
Yeah. So written in Alexandria, but at this time, scholarship was written in Greek. Yeah.
As a reminder for our online viewers, go ahead and type your questions in, and if we have time, I'll read them. Let me go all the way to the back first.
Abbas Imami, could you please go back to the previous slide, next to last?
Yeah.
The Arab, from here, what I see, that's Persian writing and not Arabic. So I wonder if there is a misunderstanding of who actually wrote that. What's the name of astronomy again?
He's Ali Kushji.
That's a Persian name, and that's a Farsi writing.
Okay.
Persian.
Yeah, so I don't know how this, I believe he's writing in Syria, even though he's writing in Persian. Yeah, so I don't know the story behind that. I don't know why.
Did Ptolemy know that the Earth was spherical, or did he assume it was spherical? And did the church agree with that in the 15th century?
That the Earth was spherical? Yeah, Ptolemy knew it and he lays out some reasons for thinking it. Things like you travel north and you see different stars, the location, the times in local time. If a lunar eclipse happens, the time that it happens here in Kansas City and the time that it happens in New York is going to be different, local time, right? These sorts of things were known to astronomers, yeah. So they're able to see that the Earth is round. And the church largely people in the church largely have had no problem with it. That the Earth being round. There are a few theologians who have written flat earthers among the church fathers and scattered. Well, then there's some existing now, right? But by and large, the consensus has been since for centuries, even before Ptolemy, that the Earth is round.
Estimate the size? Didn't Ptolemy actually do measurements to estimate the size of the Earth, which were remarkably accurate for the time?
Do you know, I don't know how accurate they are. I think he gives it as too small, but I think these come up in his work on geography.
I would like to know the original Almagest. The Almagest is an Arabic name, I think.
Yeah,
given
yeah.
to it. But the original was in Greek.
Yeah.
Now, is the Greek manuscript available anywhere?
Yeah, there are Greek manuscripts. They come from much later, though. I think the oldest Greek manuscript, I think, off the top of my head, I think is 10th century. So like a lot of ancient Greek's works, even the Greek versions are known in fairly late manuscripts.
But you mentioned that Bessarion and Georg of Trebizond had the original Greek at the time.
Yeah. So these...
Where are those documents?
Where are those? Yeah, it's still existing. They're still
existing?
Yeah. So these would have been... But the thing is, though, that these are... Even though these are manuscripts that are in Greek, they're ones that are made much closer to the time of Bessarion than to the time of Ptolemy, actually. Right? They descend from the original Greek ones, but manuscripts are destroyed and lost.
And are those at the library?
Oh, the ones that he actually used.
In
Yeah.
Italy?
Yeah, I think Bessarion's library most of it ends up in Venice. So yeah, that's where they would be. Yeah.
Any questions from the west side of the room? Yeah, here we go. And Bill, and then I'll come over to you, Bill.
Are there any instances where Ptolemy's observations or Regiomontanus' observations of stars of their magnitude have actually changed from that time to this, so that contemporary astronomers can use their observations as a kind of a datum point in the changes
Oh,
of appearance
yeah,
of a
very
star?
interesting. I actually don't know. I'm sorry, I don't know the answer to that.
We have an online question from Ben. He wants to know, other than the Epitome Almagesti, what other books in the Linda Hall Library's collection have you consulted during the course of your research?
Well, the copies of the Almagest, the versions of the Almagest made by Regiomontanus, made by Georg of Trebizond, the one translated into Latin by Gerard of Cremona, that was made in the 12th century, but that was printed in 1515. That's been great to have. Also, some of the Arabic works, or the Latin versions of the Arabic works, were printed in the Renaissance, and I've been able to use a number of those. Jabir ben Aflah's book on the Almagest, and Albategni's work on the science of the stars have been great. Yeah.
I recollected that the original Almagest was overwritten on an Arabic manuscript. Do you know anything about that?
No.
That
sorry.
somehow the term Almagest means overwritten, or
Well, the term Almagest means something like the great one. It's like the great work.
Yeah.
And it's known as the mathematical syntaxis in Greek, but we know it as the Almagest. The Arabic name stuck.
One quick question. Did Regiomontanus and Copernicus ever cross paths?
No. So, they didn't.
Oh, hang on, let me come by with the microphone. Otherwise, it's dead air on live stream.
Okay. Ancient Greek astronomers also figured out the sun-centric system as well, like Aristarchus or whatever
yes.
his name is, already knew that, figured out that the Earth is not the center of the universe. Though, so like Bessarion and the others didn't know about these things.
You know what? I don't know about this. I mean, somehow Copernicus knew about this, right? I mean, he knew that Aristarchus had come up with a system with the Earth and with the sun at the center. But I don't know when knowledge of Aristarchus's ideas became known, and whether Bessarion would have known this. He may have. He very likely may have known Aristarchus. I mean, this is just a guess on my part. I don't know, but I'm guessing that even people who knew of Aristarchus' ideas thought of it as, here is a quaint old view that didn't turn into a system like we have, a system of complex mathematics that fairly accurately matches up with reality, right? It's just the very basic theory. It doesn't have all of the stuff built up to get to actual predictions, right? So they probably would have just seen it as, oh, here's a theory that was held by some ancient, and maybe looked at it and similar to the way that they would have thought, looked at many other ancient theories. Here's a theory that doesn't fit in with our worldview.
All right, thank you, Dr. Sabeta, for a wonderful talk.